Good morning, audience. Today I will give a talk on gas chromatography. First of all, why we have to give importance to the gas chromatography? There are so many analytical techniques are there. Among all the analytical techniques, the one of the important analytical tool is gas chromatography. Okay, why? Because in this case is especially we know very well that chromatography means chroma means color and graphy means separation of the two components. So, okay, and here the separation can be achieved with the gaseous mobile phase. Already we know very well that every chromatography consisting of the two phases. The one is considered as a stationary phase and second one is considered as a mobile phase. Mobile phase. Okay, and here the in the case of this particular gas chromatography technique, what is the difference of gas chromatography with other chromatography is in other chromatography techniques the mobile phase is liquid in nature, but in the case of gas chromatography the mobile phase nature is gaseous in nature. Okay, that is the major difference between the gas chromatography with other chromatography techniques. Okay, here the gas chromatography technique is broadly divided into two different types. One is considered as a gas solid chromatography and second one is gas liquid chromatography. In the gas solid chromatography, the stationary phase is solid in nature. In the gas liquid chromatography, the liquid is stationary phase in nature. Next, here the principle involved in the gas solid chromatography is adsorption. The principle involved in the gas liquid chromatography is partition. Okay, and here what type of mobile phase that are used in this particular technique? Mainly, we are using the carrier gas as a mobile phase in the case of gas chromatography. Okay, mainly what is the supporting medium in the case of this gas chromatography is column. We are using the column. What are the sample requirements in the case of this gas chromatography? The first and foremost important aspect is volatility, and the second one is called it as the thermostability. How to separate the air? Every chromatography technique is used for the separation technique only. How to separate the components by using this particular technique? Here, the separation can be done basing on the partition coefficient. The separation can be done basing on the partition coefficient. Next, here, suppose if you can take these particular components, the components are more soluble in the stationary phase, then they will travel so slower manner. The components are less soluble in the stationary phase, they travels a little bit faster in nature. They travel a little bit faster in nature. Okay, next, here one more important aspect in this case is no two components are having the same partition coefficient, are having the same partition coefficient. Generally, here I will say one more point. What is why you are giving that much importance to this particular partition coefficient? Okay, mainly what is partition coefficient? Partition coefficient is the ratio of solubility of a substance distributed between the two immiscible liquids at a constant temperature. It can be called it as a partition coefficient. Next, what is the major principle involved in this case is here here mainly the principle of separation of this particular technique is the partition chromatography. Okay, mainly just observe this particular thing how that is going to be achieved in this particular technique. So just it is a block diagram of this particular gas chromatography technique. It is having the carrier gas. Okay, and here the pressure can be controlled. It is an injector and you are having a column. It is detector and okay, and it is having a data system. Okay, and here you just observe this particular thing. Okay, and here how the separation can be achieved. Here that we have already told that the mobile phase that are used in this particular aspect is various types of the gases. What type of the gases we are using? We are using the carrier gases. Okay, and here just observe this particular technique how that can be achieved. Suppose if there is gas solid chromatography, then the solid phase is the stationary phase is is the solid. Suppose if it is a gas liquid chromatography, the stationary phase is the liquid in nature. Okay, and here we have already covered that the principle involved in the gas solid chromatography is the absorption. The principle in gas liquid chromatography is the partition. That is a basing on that. Suppose if the principle, if the stationary phase is solid, the principle is adsorption. The stationary phase is liquid, the principle is the partition. Partition. Okay, and one more important thing of this particular gas chromatography is retention time. Retention time. Okay, and here this particular retention time is majorly useful for identification of the analytes. Okay, and here one more important point in this case is what is the retention time? Popularly called it as a TR. Sometimes it can also be considered as a RT. RT. Okay, and here the retention time means that the time spent by the sample in the column, the time spent by the column in by the sample in the column, that how much time the sample is retained in the column, that is considered as retention time. Or it is having another definition, time taken by sample traveling from injection port to the detector. That may be traveling from injection port to the detector, that can also be called as retention time. Then here we will give one beautiful example. The total we're having 8 different samples are there. Okay, all these particular 8 samples are separated by using the technique that is called it as a gas chromatography. Gas chromatography. Okay, and what are the various salt? Here we have already told that. You just see this one. All these are the liquids only. One is ethanol, next benzene, secondary butanol, n-propanol, isobutanol, toluene, n-butanol, and methyl isobutyl ketone. Okay, and here just to see this one, and here the you just see and here where the all these but 8 sample mixer can be separated by using the gas chromatography techniques. Just observe another word, resolution. What is the meaning of this resolution in this case is the two peaks can be separated. That can be measured by using resolution. Especially what type of the two peaks in this case is adjacent peaks. Two adjacent peaks that can be separated by using this particular technique that is called it as a gas chromatography. Okay, two adjacent peaks that can be separated by the phenomena that is called as gas chromatography. Yes, see this one. Suppose if you can take two components like ethanol and benzene, one is ethanol and next one is benzene. These two can be separated by a resolution value of 12.6. Next, another combination is isobutanol and toluene. Isobutanol as well as a toluene. This isobutanol and toluene, these two mixer can be separated by using this particular value that is called it as a 5.6, that is called it as a 5.6. Okay, what are the various factors that can influence the components? Okay, the first and foremost impacting factor in this case is vapor pressure. Okay, and in the vapor pressure, lower the boiling point is, the higher the vapor pressure of the compound and the shorter the retention time. That's why depending upon the boiling point will influence the vapor pressure, and these will influence the retention time. Okay, and what are the various examples of low boiling solvents? Which includes diethyl ether, dichloromethane. All these are used as solvents to dissolve the sample. Next, polarity of the compounds versus polarity of the stationary phase. Okay, and here especially two different types of materials are there. One is similar and next one is non-similar. Yes, especially in the similar means that they are having a long retention times, and if it is not similar means they are having the short retention times. Okay, next to column temperature. High column temperature mainly results in very short retention time, but also in a very poor separation. Where the best separations are usually observed for temperature gradients because the differences in polarity and in the boiling points are there. Next, one more important aspect is carrier gas flow rate. Okay, and mainly high flow rate reduces the retention times, but a poor separation would be observed. And column length, yes, especially longer the columns generally improves the separation, but peak broadening will also occur due to increased longitude as well as a diffusion. Another important aspect in this case is amount of material injected. How much amount of material that are injected? Okay, too much of the sample is injected. Then what happens in this case is the peak show a significant tiling. Always the tiling should be reduced as much as possible. Okay, and suppose if the tiling is more, then the separation is very poor. Next, come to another important component, that is call it as instrumentation. Okay, and here in the case of this particular instrumentation, what you can say in this case is mainly what are the important components that are observed in this case. Mainly, sorry, one is the first important component is carrier gas. Next one is flow regulators, sample injectors, and columns, temperature, and detector. Okay, here these are the important components of instrumentation of gas chromatography. Okay, and here every component is having their own important. This can be considered as a block diagram for the gas chromatography. The instrument that are used in the gas chromatography, it is called it as a gas chromatograph. Gas chromatograph. Okay, and here also first, we will see what type of the carrier gas that will be used in these cases. The major carrier gas that are used in this case is one is considered as a hydrogen, helium, nitrogen, as well as argons are there. Okay, and next, mainly what is the role of this particular carrier gas? The cylinder or gas tank is fitted with a pressure controller to control the pressure of a gas. A pressure gauge that indicates the pressure, a molar sieve to transfer the filtered dry gas, and a flow regulator to ensure the constant rate of flow of mobile phase to the column. You should meet the following criteria. You should be chemically inert and should be cheap and readily available. You should be of high quality and not cause any fire accidents and should be best possible results and should be suitable for the sample to be analyzed and for the detectors. That's generally what about the flow rate? The flow rate is 1 to 25 ml per minute. Next, viscosity of the carrier gas that will affect the partition coefficient as it increases the resistance to flow increases and that will affect the both sensitivity as well as detection also. Generally, the hydrogen gas allows faster separation than helium. Okay, always the carrier gas system includes the various filters containing a molecular sieve to remove the water and a reducing agent for other impurities. Next, okay, especially if you can observe the various gas cylinders, every gas cylinder is having their own color. Okay, and the color of the cylinder, what is the purpose? It mainly indicates the gas that is present on the inside of that particular thing. Suppose what type of the carrier gases that are used in this case is one is considered as a hydrogen, helium, nitrogen, and carbon dioxide are commonly used. Hydrogen has low density and better thermal conductivity. However, it will react with unsaturated compounds. It is inflammable and explosive in the nature. Next, nitrogen. Nitrogen is expensive, but it gives a reduced sensitivity. Okay, and among all the gases, helium is the most preferred gas. The inlet pressure that is ranges from 10 to 50 psi and the flow rate is 25 to 150 ml per minute for packed columns and 2 to 25 ml per minute for open tubular columns. Okay, and flow regulators to measure the volume of a gas and to regulate the flow rate. Okay, and we are using the soap bubble meter and secondly rotameter. The soap bubble meter and rotameter both are used that will regulate the flow, that will regulate the flow. Next, sample injectors. Okay, and here sample injectors, always you can inject the sample by using these particular sample injectors. There are different types of sample injectors that are available in the market. Okay, and the first one in this case is direct injection. Okay, and direct injection means that it is directly injected into the heated port. Okay, how the sample injection can be carried out? The sample injection can be carried out by using the micro syringe. And here also the sample volume is various. So depending upon the type, we have already told the two types of the columns are there. One is considered as a packed column, second is considered as a capillary column. Suppose if it is a packed column, the value is 1 to 20 microliter per ml. Suppose if it is a capillary column, the volume is 10 to minus 3 microliters. Okay, and it is how the sample can be injected. This diagram will indicate how the sample can be injected. Next, here, if you can take the, in the case of the split or the splitless injector, it is a one type of injector. Okay, how this can be work? Okay, the split valve divides the sample into two parts. One is to 20, and second one is 1 is to 500. Okay, the sample portion will enter into the column, and major portion will exist through split vent. The fast evaporation and a short residence time in the linear results in a small injection plug. The splitting reduces the size of the sample to an amount compatible with the sample capacity of the capillary column. Next, another point in this case is here the split valve was closed, and it can be used for trace analysis, and very diluted samples can be involved. Here, the total sample vaporized that can be entered into the column can be analyzed. And here also, you can see these are the two modes. So we have already covered. One is a split mode, and next one is considered as a slitless mode. These are the two analyses that that are used in this particular mode, in this particular aspect. One is considered as a slit mode, and second one is considered as a slitless mode. That is the one of the important components that are going to be involved. Next, recently, in many chromatography techniques, majority of the injection can be done automatically. That's why what we are doing in this case is we are using the auto samplers. We are using the auto samplers. Nobody is one of the widely used acceptable technique. Next, okay, and one more important aspect in this thing is cold and column injection. Here, mainly the liquid sample is introduced directly into the column with a thin injection needle. The capillary needle's outside diameter is smaller than the inside diameter, especially for the capillary column. Okay, and the common internal diameter 0.32 mm internal diameter. Okay, and here the good results are generally obtained with an injector at between 20 degrees centigrade below the boiling point and 10 degrees centigrade above the boiling point of the solvent. When using low boiling solvents, the injection port has to be cold. Okay, and column injection is very suitable for the high boiling components because no evaporation takes place during the injection period. No heated injection port that can be observed. Purge and a trap. Okay, mainly it can be used for the analysis of the volatile organic solvents. Mainly it is useful for the volatile organic solvents. Okay, and here what happens in this case is here the volatile compounds are retained in adsorbent trap, which allows the purge gas to pass through the vent. Okay, and inert gas such as helium is bubbled through the water. This is known as a purging or spudging. Okay, and here the trap is a column of adsorbent material at ambient temperature that holds the components by returning them to the liquid phase. The trap is then heated and the sample components are introduced to the GC and MS. This is one of the important aspects for this particular thing in this case is pyrolysis. Okay, and here this pyrolysis GCMS, okay, that can be used to characterize the most materials, including the especially insoluble and soluble complex materials at a trace levels, often without any sample pre-treatment. For example, polymers, plastics, rubber, paints, dyes, resins, coatings, cellulose, wood textiles, and oils, etc. A sample is introduced to a heated environment and is broken down into a small stable fragments or components, okay, for the analysis. The pyrolysis involves thermal fragmentation of the analytical sample at a temperature of 500 to 1400 degrees centigrade. In the presence of an inert gas, reproducible decomposition products characteristic for the original polymer or the copolymer samples are formed. The pyrolysis products are chromatographically separated using a fused silica capillary column and are subsequently identified by interpretation of the obtained mass spectra or by using the mass spectra libraries. And especially, we know very well that for any chromatography technique, the column is considered as a heart. Okay, and here, especially if you can take these particular columns, the column is usually a narrow bore tube which coils around itself with a length that can carry over 1 to over 100 meters. The column, which can serve for thousands of successive injections, is housed in a thermostatically controlled oven. At the end of the column, the mobile phase passes through a detector before it exits an atmosphere. Okay, and next, what I mainly we have already told that packed columns. Okay, the internal diameter of the packed columns is around 2 to 4 millimeters. Okay, and here in the case of these particular packed columns, the stationary phase is deposited or bonded by chemical reaction onto a porous support. Here, one more important aspect is the choice of the gas solid chromatography. And one more important thing is carrier gas flow rate. The carrier gas flow rate is 10 to 400 ml per minute. Generally, the stainless steel or glass tube filled with particulate packing material, an adsorbent material or a support material coated to impregnated with a solid phase that are used. Okay, the internal diameter is 2 to 4 mm that is widely used. The length is 0.5 to 5 mm is used. Okay, and especially here it lowers the column efficiency. It is the how that can be done. It is a diatomaceous ether. It is mainly used for supporting of this particular storage place. How the packing can be achieved that can be shown in this particular diagram. Next, capillary columns. First one is packed columns and second one is considered as a capillary columns. A typical capillary column is a thin fused silica glass tube lined with a liquid phase or adsorbent material or having a chemical bonding layer. The internal diameter is 0.1, 0.25, 0.32 and 0.53 mm. The length is 5 to 10 mm in length, and generally this can be coated outside with a polyimide or thin aluminum film which protects the column. Okay, and generally here we are using the fused silica or stainless steel columns that are used. What are the different types of the capillary columns? Totally four different types of the capillary columns that are used. One is wall coated open tubular, popularly called it as WCOT. Support coated open tubular, popularly called it as a SCOT. And a porous layer open tubular column, okay, can be called as a PLOT. Fused silica open tubular, FS40. These are the four different types of the columns that are available. Okay, and next one. And the widely used stationary phase is polysiloxanes. Because these are the various differences between the packed column as well as the open tubular column. Okay, and they are having so much of differences that can be observed in the properties. Okay, in of the packed column as well as the open tubular columns. It is the appearance of this particular gas chromatograph. What type of detectors? For the mini chromatography technique, the detector is playing a very important role. Okay, and here the detector should be reproducible in nature. Okay, and it must have high sensitivity in nature, and it must have long linear dynamic range, and it is having the low noise is there. Okay, and it having the small volume to avoid peak broadening and resultant loss of resolution, and it should be preferably non-destructive in nature. Okay, what are the different types of detectors? Generally two types of detectors that are available. One is specific detector and next one is non-specific detector. Okay, in the case of non-specific detector, the examples which includes thermal conductivity, atomic emission and photoionization. In the case of specific detectors, the examples include flame ionization, nitrogen phosphorus, and flame photometric, and helium argon ionization, electron capture, and chemiluminescence are used. Okay, and in the same fashion, they can be categorized into two types. One is destructive and non-destructive. Okay, these are the various types of detectors and how it will work. And the first one is considered as a flame ionization detector, and it can be popularly called it as FID. They can be called it as a flame ionization detector. It is having the very what is the principle involved in the flame ionization? Flame ionization. Okay, a flame is produced by burning the hydrogen gas in the presence of an oxygen array. Okay, and here the detection of ions formed during the combustion of organic compounds in a hydrogen flame. A definite potential difference is maintained between the two electrodes. The generation of these ions is majorly proportional to the concentration of the organic species in the gas stream. What are the major advantages? It is having the advantages of sensitivity and a wide dynamic range, and having the mass sensitive and concentration range. And second one is electron capture detector, and popularly call it as ECD, electron capture detector. Okay, the principle involved in this case is by using the various electronegative atoms such as halogens are used. The sample is carried into detector by the carrier gas, and electron absorbing N-light molecules capture the electrons and thereby reduce the current between the collector anode and a cathode. This easily uses a radioactive beta particle emitter. Okay, and here the N-light concentration is proportional to the degree of electron capture. Okay, and it is also having the very good advantages. Okay, and it responds to the halogen containing organic compounds such as pesticides and various polychlorinated biphenyls. Okay, and it is very much highly sensitive towards halogens, peroxides, quinones, and nitro groups. Okay, and third one is photoionization detector, popularly called as a PID. Okay, and it is uses a 10.6 electron volt lamp with a high voltage power supply. Okay, it is a diagrammatic representation of the photoionization detector. And third important thing is nitrogen phosphorus detector, and popularly called it as NID, nitrogen phosphorus detector. Here what we are using in this case is we are using the hydrogen or air flame through which the sample is going to be passed. Generally it uses a rubidium cesium bead which is heated by a coil over which the carrier gas is mixed with the hydrogen. Okay, and mainly the nitrogen phosphate detector is used for the herbicides analysis. Okay, next flame photometric detector. Okay, and mainly it is uses the chemiluminescent reactions of these compounds in hydrogen or air flame as a source of analytical information that is relatively specific for substances containing two types of atoms. One is sulfur and phosphorus. The existing species for the sulfur compounds is excited to S2 and lambda max is 394 nanometers. The emitter for the phosphorus compounds in the flame is excited to HPO. The lambda max is 520 526 nanometers. It is the block diagram of the flame photometric detector. Next, one more important aspect in the case of the gas chromatography is derivatization. Derivatization. What is derivatization? Derivatization is the process of chemically derivatization. One can be converted into another. They can be called it as a derivative. Like that, it is a process of chemically modifying a compound to produce a new compound which has properties that are suitable for analysis using a GC or HPLC. The chemical structure of the compound remains the same and just modifies the specific functional groups of reacting compound. The derivatization is needed in the GC, HPLC, or UV visual spectroscopy. In these techniques we are using, why we have to derivatize mainly sometimes the sample is not directly injected into the gas chromatograph. Why that is happens? Because of the poor solubility in organic solvents, because of the high volatility, because of the lack of volatility, because of the absence of the chromophore or fluorophore or electrophore. Okay, and next always we have to will get a better separations with increased resolution and response. Okay, and there is a what type of derivatization that can be done. One is a pre-column and post-column. Okay, in the pre-column derivatization of the sample, in the post-column derivatization of the effluent. These are the two things that can be achieved. Next, what are the common methods of derivatization? The important methods of derivatization is one is silylation, next to alkylation, next to acylation, next to chiral derivatization. Okay, these are the different things. These they can be call it as a derivatization. Okay, and all the things are having their own advantages. Okay, and here mainly what happens in this case is substitution of active hydrogens. Mainly what happens in this case, substitution of the active hydrogens that can be substituted of the one the compound to derivatize with a variety of the functional groups. Okay, here the group the H is there in the R1, then that can be goes to R2. Okay, and the derivatization can be achieved on this process. One group can be converted into another group. Another group. Next, in the silylation, one of the important aspect is the active hydrogens are displaced by the silyl group. One of the important aspect is the TMS, tetramethyl silane. Tetramethyl silane. Second one is acylation. Active hydrogens react with the carboxylic acid, derivatives of carboxylic acids to form the esters, thioesters, and amides. Okay, and the T which includes acetic anhydride, trifluoroacetic acid, trifluoroacetic anhydride, trifluoro yeah, yeah, acetylmazole and pentafluoropropionic anhydride, N-methyl iso trifluoroestamide. Okay, next alkylation. It involves the replacement of active hydrogens of the type described previously with aliphatic or aliphatic aromatic group. Next, one of the important aspect is the causality because of the okay here what is causality? It can be caused by the existence in the molecule of at least one tetrahedral carbon atom is secured with that are different. Okay, and here one more thing in this GC is headspace analysis. So what is the headspace sampling? Headspace sampling is a method that is used in gas chromatography to separate analytes in liquids and solids from complex matrices. They see typical examples include water, effluents, soil, food, and beverages. Okay, and next, what are the different types of